This is the magnetic field sensor. So it's used in several of our different manuals, and so it shows up in physics, middle school, and so it's a useful device to have. The sensitive part of the detector is right down here at the tip, and so what it does is it measures magnetic fields that come in perpendicular to this white tip. It's what we call a Hall probe, and so what you want to do is move this relative to a magnet, and you could measure maybe things about the strength of the magnetic field as a function of distance from the magnet. There's a nice lab that uses electromagnets where you make an electromagnet and vary the number of turns on a nail, and to be able to do that. This tip down here is also flexible, so we can move it perpendicular to the original direction. So there are some labs where you may want to do that. You have it set in one setting, and then you move it, and look what happens to the strength of the field when you've changed the orientation of the sensor. This is a multi-range sensor, and so there's a sensitivity switch here. So there's a high and low amplification setting. The high amplification is actually the smallest number, and so if you're looking at a fairly weak magnet, you can do the high amplification, and if you have a strong magnet, you could move it to the lower amplification. So it's a 20-fold difference in the amplification there. So now we're ready to collect some data, and I have a magnet here. It's just an old speaker, and I'm just going to make some measurements around it just to give us a reading there. So I'm going to plug it in. It's an analog sensor, so we plug it into the analog port there. I'm going to collect some data, and what I'm going to do is move the magnetic field sensor closer to the magnet and then move it away from the magnet. And I'm interested in looking at this as a time graph. The default setting for the device is a 10-second time-based collection, and to begin collection, I'm going to press the start button here, and I move the sensor closer to the magnet. I move it away from the magnet, and then when the run is complete, it's going to auto-scale the graph, and what we're looking at there is the strength of the magnetic field relative to its position. And so as I got closer, it ended up with a larger negative number in this case, but then as I moved away, it got smaller. So again, this sensor is used across the curriculum. It's very good to have. It allows students to measure magnetic fields in a way they haven't done before. They've discussed north and south, but they haven't discussed the actual quantitative measurement of the magnetic field strength.